Welcome to Understanding Evaporation, a comprehensive guide to the fascinating process of liquid transformation into vapor, presented by Quick Video Science. What is evaporation? It's the physical process where liquid water transforms into invisible water vapor when surface molecules gain enough kinetic energy to escape the liquid phase. This occurs below the boiling point and is driven by solar energy. The rate is affected by temperature, surface area, and humidity. The science behind evaporation involves molecular movement. Heat energy increases water molecules' kinetic energy, enabling them to break intermolecular bonds. As temperature rises, molecules move faster, and more gain sufficient energy to escape the liquid surface and become vapor. Evaporation involves a phase transition. In liquid, molecules move past each other. Evaporation is the transition to gas, where molecules gain enough energy to break all bonds and disperse as vapor. Multiple environmental factors affect the rate of evaporation. Higher temperatures provide more energy, increasing the escape rate. Wind carries away water vapor, reducing humidity and accelerating evaporation. Lower surrounding humidity also promotes faster evaporation. Temperature is the primary driver. In cold water, molecules have low kinetic energy. Increased temperature in hot water gives molecules more kinetic energy. High-energy molecules overcome intermolecular forces and escape as water vapor. Wind affects evaporation by carrying water vapor away, preventing saturation of the air layer above the water. This continuous removal maintains lower local humidity, sustaining the concentration gradient that drives continuous evaporation. Surface area significantly impacts evaporation. A larger surface area exposes more molecules to the air, increasing the evaporation rate. Containers with a deep, narrow opening minimize surface area, dramatically reducing evaporation. Evaporation is evident in daily life. Drying clothes involves water evaporating from wet fabric. Hot beverages cool as steam escapes and water evaporates. Swimming pools lose water through continuous surface evaporation, which is faster in warmer weather. Puddle evaporation begins with rainwater accumulation. Sunlight transfers heat to the water, increasing its temperature. Water molecules gain energy and transition from liquid to vapor, causing the puddle to dry up. Evaporation is the critical first step in the global water cycle. Solar energy turns liquid water into vapor. This is followed by condensation, precipitation, and collection, sustaining the cycle that redistributes fresh water globally. In nature, ocean evaporation is the largest source of atmospheric water vapor, leaving salt behind. Plants release water through transpiration. Evaporation and transpiration combined form evapotranspiration in ecosystems. Sweating is a mechanism of thermoregulation. The evaporation of sweat removes heat energy from the body, maintaining core temperature. As sweat evaporates, it absorbs energy, creating a powerful cooling effect. Evaporation rate is scientifically measured in millimeters per day. Evaporation pans measure water loss under controlled conditions. Weather stations use sensors and mathematical models to calculate evaporation rates. Evaporation rates increase exponentially with temperature, demonstrating the powerful relationship between heat energy and molecular movement. Higher temperatures provide more kinetic energy for faster escape from liquid surfaces. Industrially, evaporation concentrates solutions by removing solvents. It is essential for separating salt from seawater and is used in wastewater treatment. In food processing, it removes moisture for products like milk powder and concentrated juices. The key difference between evaporation and boiling is where they occur. Evaporation happens at any temperature, only at the liquid surface, while boiling occurs at a specific temperature throughout the liquid. In renewable energy, solar power drives evaporation systems for desalination and water purification, offering sustainable, zero-emission solutions. Advanced solar thermal systems enable efficient purification through evaporation condensation cycles. Evaporation is vital for weather and climate. Water vapor rises, cools, and forms clouds, driving weather patterns. High evaporation rates can lead to drought conditions and impact agriculture, making management crucial for water resources. To control evaporation and reduce water loss, windbreaks can decrease evaporation by up to 30%. Pool covers can prevent up to 95% loss. Monomolecular chemical films reduce evaporation by 20 to 50% on water surfaces. In agriculture, drip irrigation reduces surface evaporation by up to 60%. Mulching cuts evaporation rates by 25 to 50%. Watering during the early morning or late evening minimizes evaporation losses by 30 to 40%. You can observe evaporation with simple experiments. Measure water levels in different locations, or record how long it takes for a puddle to evaporate under varying temperatures. You can also observe salt crystals forming as salt water evaporates. Climate change impacts evaporation significantly. Rising temperatures accelerate evaporation rates, disrupting water cycles. This leads to more extreme weather events and varying water availability worldwide. Evaporation is essential to the global water cycle, with oceans contributing most atmospheric water vapor. It is a scientific process where molecular kinetic energy overcomes intermolecular forces, driving weather and influencing ecosystem health. Thank you for learning with Quick Video Science. Understanding evaporation helps us appreciate the amazing processes happening around us every day.